This is Tom, and this is his colleague Michael. They work for a small company producing small batches of parts and materials of all kinds and finally assembling them. Welding, chamfering, drilling, sawing, grinding, polishing, mounting are all part of their daily routine.
If we have to finish this job by Friday, we're going to need some help.
You're so right. Hey, it'd be great if we could get a robot to help us, eh?
A robot? Yeah. Sure.
Well, why not? We could have some sort of industrial robot. Look at the automotive industry. I mean, they've got loads of robots that do all sorts of jobs, haven't they?
Well, yes, but they can only do what they were built for. Here we have to process different parts all the time. So who's going to program this robot again and again? Not me. I don't feel like sitting at a keyboard half the week until something finally happens.
Look, don't worry. Programming a robot can be a lot easier than you think. We could just show the robot what it's supposed to do. Listen, imagine this is our workpiece, and this is our robot.
Okay. It's insensitive, it's deaf, dumb, and blind.
Yes, but it moves with great precision. Now, if it's supposed to drill holes here, I just show it the positions, starting here, 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 and finishing here. The robot remembers the coordinates and repeats the procedure, and that's it.
Whoa, that thing is dangerous. It belongs behind a fence.
Not if it's equipped with an anti-collision system. Huh? And if we give it a soft reaction to touch, besides making it lighter, it wouldn't do any harm even if it did crash into something or someone.
Not bad. So you could actually work safely in the same workspace as the robot.
Right. And because the robot is now so light, you could easily move it from one location to another.
Wow. So, you could just actually carry it across to the shop floor and train it to load the machines. Ah, but wait a second. But for detecting complex parts, this isn't precise enough.
Well, to simplify the programming, the robot could be equipped with a camera or a 3D sensor so that it could detect the exact positions of the workpieces and choose the best one to grip next.
Yes, yes, of course. And then it might even understand spoken orders.
Hey, why not? Place pump case in workpiece carrier. Hey!
Hey, what's up with you two? There's work waiting to be done. And what's that thing over there?
We are just inventing a robot to do routine work. Our robot can already work wood and feed the workpiece carrier.
And it's extremely easy to teach. And,
I bet it costs a fortune.
well, no, not really. It wouldn't cost any more than a milling machine. And you needn't buy it immediately. Perhaps you could just rent it for a certain period of time or a certain production quantity.
Sounds all right, but don't you have to have special training to operate it, which also costs?
Well, yes, of course, the staff will still need training, but no more than for any other new machine.
Yes, but...
You know what? I think we need to send the management on a training course to show them the advantages of the robot.
OK. So, what are the benefits? Is it versatile?
Absolutely. Just plug in and produce.
For handling? Working different materials? Assembly?
Yeah.
Feeding machines?
Yes.
But it can't be used for drilling, milling or grinding, can it?
I think you've got to see it as a multi-purpose tool where you decide what application to use it for.
But she's right. For grinding, we might need a different type of robot. One that is capable of applying high forces with high precision.
And it's still got to be lightweight, with collision detection and all that.
Right. What about a robot that's made up of rigid, lightweight modules? That might be the answer.
That's a robot too.
Yes, it is. It may look a bit unusual, but these variable parallel kinematics provides the stiffness and high forces required for applications like grinding.
But grinding has to be absolutely accurate. How do you intend to manage the programming?
Well, actually, that's quite easy. Either by demonstration or, if we need to be more accurate, we could feed the robot directly with the CAD data. And then, to check the exact positioning, we just move the tool to a number of reference points. The robot then compares the CAD data with the real object and automatically generates the program that's needed.
Well, someone really should invent such versatile robots.
The leading European research institutes and robot manufacturers have formed a consortium to develop a completely new generation of robot systems specially designed to meet the needs of small and medium-sized enterprises. SME Robot, the European Robot Initiative to strengthen the competitiveness of small and medium-sized enterprises in manufacturing.